Hello everyone, thank you very much for watching this video. My name is Liang Wang, and on behalf of all the authors, I'm introducing you to our paper published in iMeta. The title is Lepidium meyenii Walp Maca-derived extracellular vesicles ameliorate depression by promoting serotonin synthesis via the modulation of gut-brain axis. As you may know, depression is a mental disorder that affects 280 million individuals globally. Recent data released by the World Health Organization have demonstrated that a 25% increase in the global prevalence of depression due to the spread of COVID-19. It has been found that the dysfunction in microglia and neurotransmitters, etc., may contribute to the development of depression. Traditional antidepressants, like monoamine oxidase inhibitors, have been shown to have particular antidepressant efficacy. However, their adverse effects, such as sexual dysfunction and sleep disruption, couldn't be ignored. Thus, there is an unmet need for the development of safe and effective antidepressant. Recently, Maca and its extract have garnered significant attention due to its potential neuroprotective and antidepressant effects. In this study, we successfully isolated and purified extracellular vesicles from Maca, and the behavioral tests revealed that Maca extracellular vesicles dramatically recovered the depression-like behaviors of unpredictable chronic mild stress mice. In general, this study sheds light on a novel approach to depression treatment using plant-derived extracellular vesicles. Maca extracellular vesicles were first isolated from Maca juice. Next, we investigated the in vivo uptake of Maca extracellular vesicles in mice using a spectrum imaging system. Immunofluorescence staining confirmed that Maca extracellular vesicles could pass through the blood-brain barrier and accumulate in the brain. Then, fecal and blood samples were collected from the mice, and the mice were killed after the behavioral tests were completed. Maca extracellular vesicles administration improved depression-like behaviors in UCMS mice, as shown by the decline in the extended immobility time in the tail suspension test and the forced swim test, etc. This data suggested the therapeutic potential of Maca extracellular vesicles in treating depression. Next, we investigated the dynamic changes of gut microbiota in mice from across 4 groups using 12 fecal samples. The differential analysis of bacterial abundance at genus level indicated that the general Lactobacillus, Akkermansia, Dubocella, and Faecalibacillum might be associated with the effect of UCMS and Maca extracellular vesicles. Given gut microbiome often modulates the host metabolic pathway, here we used gas chromatography mass spectrometry-based metabolomics to compare the metabolic characteristics of the 4 groups. Through the analysis, we found that the amount of serotonin was significantly lower in the UCMS group but higher in the UCMS plus Maca extracellular vesicles group, suggesting that UCMS may affect serotonin biosynthesis. As the identified altered metabolites were closely associated with serotonin production, we next investigated whether Maca extracellular vesicles modulate the production of monoamine neurotransmitters. According to the results of our study, it suggested that the serum monoamine neurotransmitters levels, particularly serotonin, may contribute to the antidepressant effects of Maca extracellular vesicles. It's already known that abnormal serotonin and BDNF signaling are associated with the progression of depression. Through this study, the co-regulation of serotonin and BDNF signaling is also well established. Taken together, this study reports for the first time the successful isolation and characterization of Maca extracellular vesicles, which exhibit antidepressant effects in UCMS mice. These effects were accompanied by alteration in depression-related fecal microbiota and enhanced gut serotonin metabolism, as well as elevated serum serotonin concentrations.